Hello students, welcome to EPG Pathshala. I am Professor Pankaj Madan from Faculty of Management Studies, Gurukul Kangadi Vishwavidyalaya, Haridwar. Today, we are going to talk on module Analysis of Variance and Experimental Design, Way Anova, under the paper Quantitative Techniques for Management Decisions. After the completion of this module, the student will understand analysis of variance, a two-way ANOVA, difference between one-way ANOVA and two-way ANOVA. He will also understand what is blocking in two-way ANOVA, and he will also know the design of a general ANOVA table for a two-way classification. In statistics, the two-way analysis of variance is an extension of the one-way ANOVA that examines the influence of two different categorical independent variables on one continuous dependent variable. In two ways analysis of variance, two criteria or two variables or two attributes are used to analyze the difference between more than two population means. The two-way analysis of variance can be used to first explore one criteria or a factor of interest to partition the sample data so as to remove the unaccountable variation and arriving at a true conclusion. Second, to investigate two criteria or factors of interest for testing the difference between sample means. It can also be used for an interaction between, for considering an interaction between two variables. Let's see the difference between the one-way ANOVA and two-way ANOVA. While making a comparison, first see how the meaning of the two ANOVA and a two-way ANOVA or one-way ANOVA and a two-way ANOVA, it differs. Now, in one-way ANOVA hypothesis test, it uses to test the equality of three or more population means simultaneously using variables. But I have not discussed that how many variables. So, if we talk about the independent variable in ANOVA, it is 1. We can say that ANOVA is using one variable to test the hypothesis, or sometimes it is also called as an attribute. While in two-way ANOVA, it's a statistical technique where the interaction between the factors or influencing variable can be studied. But in this case, the difference is that it is using two variables or it is using two attributes to do a hypothesis testing or testing two or more population but based on two attributes. So this is a two-way ANOVA. In this, in one-way ANOVA, there are three or more levels of one factor, while in a two-way ANOVA, the effect of multiple levels of two factors is studied. Now, if we talk about the number of observations, then in one-way ANOVA, the number of observation need not be same in each group, while in two-way ANOVA, the number of observation need to be equal in each group. If we talk about the design of experiments, so while discussing the design of experiments, we discussed the principles of design of experiments, and in which we discuss the three principles. So the one-way ANOVA should satisfy only two principles out of that, and a two-way ANOVA has to satisfy all the three principles of design of experiments. What is blocking in two-way ANOVA? In two-way analysis of variance, we are introducing another term called as blocking variable that is used to remove the undesirable accountable variation. A block variable is the variable that the researcher wants to control, but in not the sample or a population or a treatment, but in a variable of interest. The term blocking refers to the block of land and comes from the agriculture origin. The block of land might make some difference in the study of growth pattern of varieties of seed for a given type of land. R.A. Fisher designated several different plots of land as blocks, which he controlled as a second variable. Each of the seed varieties were planted on each of the blocks. The main aim of this study was to compare the seed varieties, which were the independent variables. So, he only wanted to control the difference in plots of land. Therefore, he called it as a blocking variables, means the plots of land should not be different or they should not vary, only the impact of variation in seeds or seed varieties should be studied or tested. Now, let us look at the general ANOVA table of a two-way classification. So, here you can see the sources of variation, the sum of square, degrees of freedom, the mean square and the test statistics. Now, in this, the sources of variation, we can see the three parts of that: between column variation and between rows or within column you can say, and then we can say residual error. And here if you see the sum of square, then SSTR is the sum of square between columns and NSSR is the sum of square between rows. We also need to find out the degrees of freedom, because in F ratio you need to find out the degrees of freedom of numerator as well as denominator. Degrees of freedom of the between column variance and within column variance. So, degrees of freedom here is C minus 1 and between rows it is R minus 1. And for residual error, it is the multiplication of the two, that is C minus 1 into R minus 1, and total is the N minus 1. If you see the mean square, then MSTR is equal to SSTR upon C minus 1 and MSR is equal to SSR, that is sum of square between rows upon R minus 1. And the residual error is MSE is equal to SSE upon C minus 1 into R minus 1, dividing by the degrees of freedom. And when you calculate the F ratio for the population or the treatment, it is MSTR upon MSE, or if we are talking about the blocks, then it is MSR upon the MSE. Here you can see mean square MSTR, I have already told you, is mean sum of squares, and MSR is mean square of squares, that is of rows, and MSE is mean sum of squares, that is error. So, the total variation consists of the three parts: variation between columns, variation between rows or within column, then actual variation due to random error. The degrees of freedom associated with SST is where CR minus 1, where C and R are the number of columns and rows respectively. So, how do we do a decision whether to calculate the null hypothesis, whether to accept the null hypothesis or whether to reject the null hypothesis? So, in this case, when we have found out the F calculated, and based on the degrees of freedom of numerator and the denominator, when we have found out the f, the critical value from the table, if the f calculated is less than the f table, we accept the null hypothesis HO, otherwise we reject the null hypothesis. Let's take an example and understand that how we can compute or how we can do the hypothesis testing with more than two populations. Question 1. The following table gives the number of refrigerators sold by 4 salesmen in 3 months, that is May, June and July. And we want to see, is there a significant difference in the sales made by the 4 salesmen? Is there significant difference in the sales made during different months, or there is no difference between the sales of these 4 salesmen? For this, let us take a null hypothesis that there is no significant difference between sales made by 4 salesmen during the different months. The given data are coded by subtracting 40 from each observation. Now, calculation for the two criteria, that is month and salesman analysis of variation, is shown in the table. So, on one side it is the salesmen, their sales, and on the other side you can see the month. Now, here T is the sum of all the observations in 3 samples of months. Now, if you see this table, and when you have decreased 40 from 50, it is giving 10. And when you have decreased 40 from 46, it is giving 6. And like that, in July, it is giving -1 because the value was given 39. And here we have made the sum of rows and also the sum of columns. So you can see the sum of column A is 15, and when we have squared it, it is 137, and like that 12 and 80 for B, and for C it is 18 and 164, and for D it is 3 and 27. Now we are trying to compute the correction factor, as I have told you in the other module that one of the way of doing is by using the correction factor. So in correction factor, I have already told you the formula for correction factor is T, that is sum of all observation in the sample, square of that is T square upon N. So here T is 48, so 48 square upon 12. And how it is 12 calculated? That is 4 salesmen and 3 months. So N becomes 12. So it comes out to be 192. Now to find out the sum of squares between the salesmen, and that is column, we have added 15 square upon 3 plus 12 square upon 3 plus 18 square upon 3 plus 3 square upon 3, adding all these and then subtracting the correction factor, that is 192 out of that, and it brings SSTR value as 42. Then find out sum of squares between months, that is rows. So here it is 17 square upon 4 plus 29 square upon 4 plus 2 square upon 4, and if we add that and then subtracting minus 192, that is the correction factor, it gives the value 91.5. Now to find out the total sum of square, that is SST, we add the squares of x1, x2, x3 and x4, that is 137 plus 80 plus 164 plus 27, and subtract again the correction factor out of that, and it makes it 216. Now putting the formula for SSE, that is SST minus sum of SSC plus SSR, it shows 216 minus 42 plus 91.5. and the value of SSE comes 82.5. The total degrees of freedom is n minus 1, that is 12 minus 1, that is 11, and for column it is C minus 1, or it is columns, there are 4 columns, so it is 4 minus 1 is equal to 3, and for rows, since the rows are 3, it is 3 minus 1 is equal to 2. So multiplying these two degrees of freedom, we get C minus 1 into R minus 1, that is 3 into 2, and how we have defined that previously, the C minus 1, and that is the residual error. So here in this question, the residual error, it is coming as 6. Now putting up into commuting or calculating that, so SSTR, to calculate the MSTR, it is SSTR upon C minus 1, that is 42 upon 3, it is 14. MSR is equal to SSR upon R minus 1, that is 91.5 upon 2, and it shows at value 45.75. And MSE is equal to SSE upon, that is C minus 1 into R minus 1, that is 82.5 upon 6, 13.75. Let's put it into a two-way ANOVA table and understand that how the null hypothesis can be accepted or rejected. Now, between salesmen, the sum of square has come out to be 42, degrees of freedom is 3, and MSTR, the mean square, is coming out to be 14. Then between months or within rows, you can say it is sum of square is 91.5, degrees of freedom is 2, and how we have got this degrees of freedom 2, that is 3 rows minus 1, that is R minus 1, that is 3 minus 1, that is 2, and you can see the above calculated value of MSR, that is 45.75. Then residual error, we have got 82.5, that is the sum of squares, and degrees of freedom as 6, so mean square is 13.75 we have calculated. So to calculate the F ratio becomes the between column variance upon within column variance. So it is 14 upon 13.75. So it is 1.018. And as far as the block is concerned, it is 45.75, that is MSR upon 13.75, that is MSE, and it comes out to be 3.327. The table value of F is equal to 4.75. For degrees of freedom, DF1 is equal to 3 and DF2 is equal to 6 and alpha is equal to 0.05. Since the calculated value of F is 1.018, as you can see from the table, and it is less than its table value, the null hypothesis is accepted. Hence, we conclude that sales made by the sales do not differ significantly, because the null hypothesis is there is no significant difference between the sales persons. All the salesperson makes the same sales or equal sales. For the second part, the F value is 5.14 and degrees of freedom is DF1 is equal to 2 and DF2 is equal to 6 and alpha is equal to 0.05. Since the calculated value of F block is equal to 3.325, which is less than the table value, the null hypothesis here is again also accepted. Hence, we calculate that the sales made during the different months do not differ significantly. Let's see another question in which again two parameters or two attributes or two variables are used. Look at this question. The question says, to study the performance of 3 detergents in 3 different water temperatures, the following whiteness readings are obtained with specially designed equipment. So if you see this table, on the column side, it shows detergent A, detergent B and detergent C. So this is one attribute which is known as a detergent, a category of detergents. The other attribute which is specified in rows is the water temperature, and this water temperature is again attribute 2 or variable 2, and water temperature has been categorized into cold, warm and hot water. And the readings which you are seeing in this table, the 57, 55, 67 and all that, these are the whiteness of the cloth which has been washed with different detergents in different temperatures of water. So we need to perform a two-way analysis of variance using 5% level of significance. So here, let us take the null hypothesis that there is no significant difference in the performance of the three detergents due to water temperature, and we can say the otherwise also or vice versa also, that is the alternative hypothesis, that there is a difference. Now the data are coded by subtracting 50 from each observation. And why we have subtracted 50? Whole of the statistics is for making ease or putting the statistician at ease. So decrease this values of a higher numerical values, putting it to the lower form so that less computation is required. We have subtracted 50 from each observation. And you can see the values 57 minus 50, that is 7, and then 49 minus 50, that is minus 1, and like that. And you can see the total of A column, the column sum is 10. And if we square these values and find out the sum of that, that comes out to be 66. For B, it is 3, and it's B's, the value of x2 and its square, and if we find out the sum, it is coming out to be 45, and same as in it is in C. Then we have done the row sum also, and the sum row of cold water is 29, warm water is 19, and hot water is 8. T is the sum of all observation in the three samples of detergents, and it comes out to be 56. Here again we have used the shortcut method, in which I have already explained that we are using a correction factor, and the correction factor is equal to T square upon 2. So it is 56 square upon 9, and when we calculate it, it comes out to be 348.44. Then let's move to again the generic way of solving the ANOVA problem. We have to find out the sum of squares between detergents, and or you can say between column variance and within column variance. So SSTR is, we have added the 10 square upon 3, then the 3 square upon 3, and the 43 square upon 3. We sum up and then minus the correction factor. So it comes out to be 304.22. Second, we find out the sum of square between water temperatures. So it is 29 square upon 3 plus 19 square upon 3 plus 8 square upon 3, sum of that and minus the correction factor, which is 348.44, and its value comes out to be 73.55. Now we find out the SST, that is the total sum of squares, and that is by adding the x1 square, the x2 square plus x3 square minus the correction factor, that is 66 plus 45 plus 677 minus 348.44, and it shows the value of 439.56. The SSE is equal to SST minus SSC plus SSR. So it is 439.56 minus 304.22 plus 73.55, and it gives the value 61.79. SSE is the sum of square due to error, SST is the sum of square, that is total, SSC is the sum of square due to column, and SSR is the sum of square due to rows. Now let's find out the MSTR, MSR and MSE. So MSTR is the mean square column, MSR is the mean square of rows, and MSE is the mean square of error. So MSTR is equal to SSTR upon C minus 1, that is 304.22 upon 2. Column we have 3, so 3 minus 1 it is equal to 2, and it comes out to be 152.11. MSR is again SSR upon R minus 1, that is 73.55 upon 3 minus 1, that is 2, and its value is 36.775. MSE is SSE upon C minus 1 into R minus 1, and that is 61.79 upon 4, and it is equal to 15.447. Now let's compute variation or the variance between detergents. So its sum of square is 304.22, degrees of freedom is 2, and the mean square is equal to 152.110, and the variance ratio, that is the F ratio, is equal to 152.11 upon 15.447, and the 15.447 is the mean square or the error. So it comes out to be 9.847. So this is the F calculated. Now F calculated for the block is equal to 36.775, that is MSR, upon 15.447, that is MSE, and it comes out to be 2.380. Now since we are calculating the F ratio, so now to test the hypothesis, we need to compare the value of F calculated and F table. So based on the degrees of freedom, the F table is coming out to be F is equal to 6.94. The degrees of freedom are 2, and dF1 is equal to 2 and dF2 is equal to 4. So looking at the F distribution table, mostly given at the back of the statistical books, you can find out the value of F table, and that is also called as the critical value. Now here you can see that the F table value is less than the calculated value, or you can say the calculated value 9.847 is greater than the table value. Therefore, the null hypothesis is rejected. Hence, we conclude that there is a significant difference between the performance of three detergents. Let's calculate for the different waters or different temperatures. Here, the calculated value of F block is equal to 2.380, and with the degrees of freedom dF1 is equal to 2 and dF2 is equal to 4 at 5% level of significance, the F calculated is 2.380, and F table, from the table F distribution table, it can be depicted as 6.94. Here also you can see that F calculated is, here you can see that F calculated is more than F table. F table is more than F calculated. 6.94 is greater than 2.380. Therefore, in this case, the null hypothesis is accepted. Hence, we can conclude that water temperature do not make a significant difference in the performance of the detergents. So, the students, let's now summarize what we have learned in this module. In this module, we have understood the difference between one-way ANOVA and two-way ANOVA. We also understood that blocking or blocking variable in analysis of variance technique is used to remove the undesirable accountable variation. We also learned that in two-way ANOVA, two variables or attributes are used to test the hypothesis, and the steps of two-way ANOVA were also explained in detail, specifically a comparison between F calculated and F tabulated values. In case of F calculated population, it is calculated by dividing MSTR, which is mean square of columns, by MSE, that is mean square error, while in case of calculating F block, means for a block test, it is calculated by dividing MSR, that is mean square of rows, by MSE, that is mean square error. The mean square error or the MSE is the mean of the squared error used to judge the quality of a set of errors. Thank you very much.